I'm still convinced that you do not need an intelligent machine, but an intelligent designer. And I will never accept that one of those tools is telling me how the architecture of the Werner Sobek branch offices should look like. Never. Werner Sobek is an interdisciplinary group of people spread all over the world, which has been founded in 1992 as a one-man company. Now, in the meantime, we are about 350 to 380 people all around the world. I founded the company a couple of years after finishing my academic studies, becoming a doctor of engineering science, because there was always the intention to create buildings in a total another way than my competitors or the other ones did. And the company stands for design, architecture, and engineering in all its aspects as an entity of work. The main office and the first office is here in Stuttgart, in the southern part of Germany, the automotive town of Germany, where we have Mercedes-Benz and Porsche. And since during the last 27 years, I also founded offices in New York, in Moscow, in Istanbul, in Dubai, in Buenos Aires, Hamburg, Berlin, and so on.
My name is Wolfgang Sundermann. I'm working since 25 years together with Werner Sobek. In 1994, I came to the office, and when we started, we were very small people working in one room. There were 4 engineers working in one room, and so we had a very small staff when we started. I indeed started studying engineering. I was not sure whether to study architecture or engineering. This was a little bit a critical time in the mid of the 70s in the last century, when we had those 2 oil crises, and the markets in Germany were difficult for young people. So I initially wanted to become a stage designer, but becoming a stage designer at that time was too difficult. So I decided to study architecture, then I switched to engineering. I studied engineering, and after 2 or 3 weeks I decided that this is not the right thing. I had to also add architecture. So I applied for an architectural study place, which I then got in Stuttgart too, and then I studied both disciplines. The engineering professors, which always told the students how to analyze something. I said, I'm not analyzing such stupid stuff. On the other side, the architects, they were mostly synthesizing. They were on the creation of things, but their capability to analyze the product from a more scientific standpoint was limited. So I thought, if the ones are able to synthesize and the other ones are capable to analyze, if I do both, then I'm capable to run this iterative process between sketching something, correcting it, redoing it, correcting it, which is the basis of our work. And to cut that into 2 disciplines and 2 different people at the end does, in my opinion, not make any sense. So I decided to study a little bit of textile engineering, car body design, aircraft engineering. This is how I became a multidisciplinary person.
I don't feel as an architect, I don't feel as an engineer.
Yeah, I myself got the very big chance from Werner Sobek in 1998 to take over the project leading for the Post Tower in Bonn. It's a high-rise building, 160 meters high. The Post Tower in Bonn came up out of a competition which was won by Helmut Jahn and his team. Werner Sobek and Helmut Jahn, they invented the so-called archineering, which means the very early collaboration between the architect on the one side and the engineers on the other side. And this leads to a very good and sophisticated building, for instance, the Post Tower.
And then the cooperation we do in our teaching as well in our research fields is with other institutions, other faculty members from aircraft engineering, textile, machine, etc., etc. And for us, this is a very self-understanding way to call the professor for aircraft engineering and to make an appointment in order to discuss a know-how transfer or technological transfer, or just to ask a question, what he would do in my position, facing a question or a problem. But there's so many know-how which you can combine, and there's tools and methods which are so precious and which are so advantageous if you combine them in order to create something new, something never seen before, that I ask myself the question since decades, why aren't these people doing this? So we do it.
The Post Tower was opened in spring 2003, and I think in this, to this time he was one of the most innovative buildings which have been done in the world. And finally this leads also to some awards what the Post Tower finally got. For instance, the CTBUH award for the most important 50 buildings in the world. And of course the Post as a client was very proud of this. And I think this is a very good result, and we're very happy about this award.
I think in total, actually, we are between 350, 380, something like this. It is quite clear, since we are doing about 60 to 70% of our turnover outside Germany, that we need a basis in other countries where we love to work, which are typically composed of 50% local people and about 50% of Stuttgart people or Stuttgart educated people. So to transfer the philosophy and the attitude on how we work to those locations. And I myself, I love to work worldwide, at least in a certain number of countries, and this is what we do, successfully since many years.
Hello, I'm Frank Heinlein. I'm in charge of public relations and communication here at Werner Sobek. So I'm covering all the offices we have in Germany and abroad. I'm in charge of books, the internet, our intranet, and whatever else there is regarding public relations. When I started, we were 42. We are 370 now. We had, in the beginning, we had one office only in Stuttgart, and now we have offices in New York, Moscow, Istanbul, Dubai, and many other places. So that is very exciting. We have a Christmas party, we have a summer outing for all employees and their families. We have a walking tour we do once a year, or some of our people cycle. So it's actually two groups. So we're trying to do as many activities as possible. So there's a sports team, etc. The table tennis team.
Mi chiamo Tilmann Schäufele, ho 44 anni e sono da Werner Sobek Design da quasi 2 anni già. Abbiamo una terrazza dove facciamo d'estate delle feste, facciamo il barbecue ogni tanto E anche quando facciamo un grande workshop all'interno, c'è sempre una persona che fa i biscotti, che fa un piccolo pranzetto, così ci organizziamo bene. Sì.
Actually, this is my casual Friday, so otherwise I would have to wear a white shirt or a light blue shirt. And as you've seen, black is our preferred color, so yes. There's a certain color code, but it's not too strong. So you have to be well dressed. That is most important. That was my decision this morning because it was so cold. I felt I needed some color in my dress.
Qui siamo degli architetti, ogni tanto ci vuole un po' di colore.
My name is Angelika Schmid. I'm structural engineer and principal at Werner Sobek. And right now I'm the responsible project manager for the new underground railway station here in Stuttgart. It's really a pleasure and very important to collaborate with colleagues to get all their ideas, discuss it, and everybody can learn from each other. And it helps for the project you're working on, but of course also for the future, for all the other projects we will work on in future. So the new railway station here in Stuttgart is a part of a huge infrastructure project which will influence the city of Stuttgart, but also the public traffic in the area around here. It is designed by the architects Ingenhofen, and we from Werner Sobek are doing the structural engineering. Collaboration is a very, very big issue in this project because we need a lot of colleagues, a lot of specialists. There are the engineers, the draftsmen, but also 3D specialists, facade engineers and architects. I mean, such a structure has never been built before, and all the planning is done in 3D, which means between all the partners, the architects and us, but also other planners. The exchange, the work was done in 3D. And of course, also this influenced the design in a special way because you have much more possibilities to go deeper into design if you have it in 3D in front of you. It is 3D printed here in our office. We have a small machine where we can do models in this size. And this is half of one of these columns, so you can think here the other half mirrored around. And this is so one of 28 columns of the station that support here the roof, at least where people walk on at the park beside. On the one hand, it's a huge project for our office. Up to 40 people were working time-wise at this project. So collaboration within Werner Sobek, but also with external partners was every time very, very important and also fruitful, I think.
The most difficult is the beginning, to come up with the idea. And then the other very important part is the transformance from the drawing into the built environment, because there it is a conflictual situation with many, many interests, especially from the contractors. They want to make money, so they make it more simple, they make it another way than you want to have it, they don't deliver the quality you are asking for. And this is where you really have to carefully look at and control them and double check them and work really hard in order to achieve what you intend to get. Why are the clients approaching us? Because we supply perfect quality, in time, in budget, and very often never seen before solutions.
So my name is Ludo Blandini. I'm a partner and board member of Werner Sobek with a special focus on innovation and knowledge management. I've been working with Werner Sobek since 19 years now. So we got, for the Kuwait International project, we started around 3 years ago with a team of around 40 people. So that was going behind my own team. People from different offices have been collaborating. So the Kuwait airport, the Terminal 2 of the Kuwait airport, is actually a new terminal for around 25 million passengers. It has to be one of the next hubs in the Middle East. And the particularity of it is that the design is parametric, completely parametric. The architect is Norman Foster. And instead of using a modular approach to the airport, as it is of the case, they changed the geometry according to certain rules, parametric rules, and that leads to a different approach in terms of engineering. So you don't calculate one element, and it's the same for 20 different cases, but every single element is changing geometries. There are different components, and this is part of the challenge we've been facing. There's a lot of prefabrication on the concrete and on the steel elements, and they bring these elements directly from site to the construction field, and they are erected. And this is actually pretty innovative for the Middle East because they can achieve high degree of precision. The interesting thing was in the strategy that we didn't work with one platform, so we decided to pick, because we are working with concrete, we are working with steel, with different treatment. We have aluminum spraying on the steel for corrosions, and all of that means we have to use always the right software, the right platform for the right use.
I'm still convinced that you do not need an intelligent machine, but an intelligent designer. And I'm still convinced that the best way to solve, to create something which we call a built piece of the environment. You also can call it architecture, but the built environment is more than we typically call architecture. It also includes bridges and whatever. I think this has to be created by the humans themselves. This is not something we should offer to the machine, because otherwise at the end you don't need the humans anymore. And this is also the fun part. It is the toughest part because it makes you sleepless and it makes you unhappy unless you have the perfect situation. But once you have it, it is also the most lucky and satisfying part. The other things you mentioned, BIM and blah blah, this is tools. It is very good that we have those developments like, let's call it digital processes. But I consider even the most complicated digital processes which we need for our own work in order to enable ourselves to realize what came out of our brain as tools and methods. And I will never, never accept that one of those tools is telling me how the architecture of the Werner Sobek branch offices or offices should look like. Never.
So my name is Romero Rios, and I work here as a project manager at Werner Sobek. I was originally born in Mexico, but I actually grew up in the US. So I grew up in Chicago and worked mostly in New York City. And then I came here to this office in Germany. I think it's a very good place where you come and learn, and you're always going to be trying to do something new, and it's always something that is not going to be boring. It's definitely going to be challenging, so that's the reason I think you should come here and apply.
There's a couple of different topics to be discussed. One, which is probably the more important one, is this not really precisely discussed question on how should we build tomorrow if we understand building as an entity. Of course, there's the functional, there is the aesthetic, there's sociological qualities, etc., which has to be treated, but where we have already sets of tools and methods and solutions. There's another issue which has been neglected for a very long time, and I think we are one of the very first ones which finger pointed on those effects. And this is the fact that the net increase of the world's population is 2.6 people per second. And if we want to supply those people with a built environment which enables them to have buildings for culture, buildings for health, for education, their own whatever house, etc., means which enables them to live in dignity and to have the ability of fresh water supply, of wastewater treatment, of garbage treatment, of health and whatever, then you minimal need about 200 tons, maybe even 300 tons of building material per person to supply the person with that. That means 2.6 people increase per second multiplied by 300 tons is around 800 tons of building material per second, which we have to scratch out of the earth, of the surface of the globe, and make houses out of it. And these 800 tons, if we produce them in a traditional way, we need plenty of energy. And the energy is typically fossil-based. So we produce plenty of emissions, which are unfortunately, in most cases, transparent, like CO2. So you don't see the problem, but the problem is out there. And those emissions, they heat up the climate. And this is the huge problem. And the building industry, if you just take what I call the embodied, the gray emissions, the emissions done during the production of the building until the first second when you move in, they are 20% of the entire worldwide emissions. Nobody talks about it. People talk about emissions caused by aircrafts and by big cruising ships in Venezia and whatever. This is all critical and problematic, or emissions caused by cars. But 20% is caused by building the built environment. Plus, another 15 to 20% comes from running the buildings. So the contribution of the building industry or the built environment, where architects and engineers are in a certain way responsible for, is huge. And the tragedy is that most of the architects and engineers even don't have an idea what they are responsible for. How much kilogram CO2 are you producing when you create 1 cubic meter of concrete? Nobody knows about. If this CO2 is in the atmosphere, how long is it lasting there? No one knows about it. It lasts there for 800, for 1,000 years. There is no mechanism which breaks the molecules into parts. They are just there. So the only chance to extract this CO2 from the atmosphere is planting trees. And the question is, how many trees do you have to plant to compensate the emission for a residential building? Nobody knows. And this is the research we are doing. And now in the meantime, we are designing CO2-free or zero CO2 apartments or zero CO2 office buildings. And we reduce the amount of material, we make the building recyclable, we use recycled materials, and then we tell the client, okay, you have to buy 25,000 trees. Plant them somewhere, and those trees, they grow and they bind CO2, and after 10 years, they have binded all the CO2 emitted by the production of your house. There is no education of the people in these topics. How many trees do you need per kilometer in order to compensate the CO2 emissions of the cars? What does it mean if I drive with my car 1 kilometer? Okay, everyone knows there is 200 grams, 300 grams of CO2 per kilometer, but what does it mean? I cannot see it. So there's the problem. And I tell the people, if you have a 50-year-old tree, the maximum per day the tree can compensate CO2 is between 60 and 100 grams
So driving with your SUV for 1 kilometer necessitates 3 to 5 trees to breathe 1 day long. And if you don't have enough trees, the emissions will cause a global warming, in addition to what we already have. And this is what needs to be outspoken out. This is what has to be placed on the table, and this relation between the facts. What is the CO2 binding capacity of a tree? What is the CO2 emission of a car? What is the gray emission of a house? How can I bring that all together? And what is the compensation quality of grass and flowers and trees? It's a very simple, at the end, lecture. But nobody is giving that lecture. And this is where we engage ourselves heavily and very intensively in talks, in lectures, in podiums, discussions, or in publications or TV interviews or wherever. It is a self-understanding basis of our work. We know those numbers, we know how to combine them, and we know how they influence our architecture. And our architecture and our engineering is influenced by it. And this is the big difference to other ones.
My name is Anastasija Saklin, and I'm working as a constructional engineer. It's a pretty cool office, actually. We have very interesting projects here. The team is very young, and the atmosphere is very friendly. I always can ask my colleagues if I have a question. It's very, very easy here.
Mi chiamo Valentina, Peluso. Sono qui da quasi 3 anni. Quasi 3 anni, ho iniziato qui con un practicum ad aprile del 2017 e poi da ottobre ho iniziato a lavorare dopo aver concluso il master. Siamo un team molto unito e sì, adesso diciamo attività di team building, di eventi in cui siamo tutti quanti insieme, ce ne sono parecchi in realtà, cioè tipo 4-5 durante l'anno. Adesso arriva la festa di Natale, siamo tutti felici e lì avremo anche occasione ovviamente di incontrare anche i colleghi dagli altri studi, quindi ci riuniremo tutti quanti qui a Stoccarda. I progetti sono super interessanti, sono felicissima io a volte mi ritrovo, diciamo, a lavorare più del dovuto, ma lo faccio sempre volentieri perché appunto non pesa, si impara tanto, è bello.
My name is Torakai. I work here as a structural engineer. I'm a project manager and I work on national and international projects. Plot 15 is a high-rise building in Moscow City. It is 275 meters tall. It is a twin tower. Both towers are sitting on a podium structure. We are building on an existing basement structure, and it's very complicated in terms of the structural engineering, but we were responsible for the general planning, for the design, structural engineering, as I said, and also for the construction itself. I'm personally involved in the structural engineering, and the most futuristic part is probably the transfer structure, as we are building a new tower, 2 new towers on an existing basement structure. The column position on the top part and the lower part are different, so we had to transfer the loads. We had wide span slabs, so we had a very high ratio of reinforcement, and bringing all these pieces together. Nowadays, everybody is talking about computational tools that we have, but in the end, we always start with a piece of paper where we bring our ideas to paper and we think through all the concepts that we have, and then we move forward to the computer. What was really outstanding in this project was the interdisciplinary workflow between our different companies in Russia and Germany, the different disciplines, the engineering and the architecture, and we developed tools, digital tools.
What we are searching for is nothing else than beauty. But a beauty you can take the responsibility for, because the beauty evolves out of a number of processes using materials and energy and creating emissions, and you have to take the responsibility for this. And you have to optimize all that stuff. And when at the very end, beauty is evolving out of that, then you are at the goal, then you have it.